Okay, so last time we ended at this, we learned that when the population standard deviation is not known, we are going to use the t-test. We did that in chapter 17. And here we learned how to construct the hypothesis for the mean when the standard deviation is unknown. So I remember last time we were able to set up the hypothesis. So we are going to do a full example. So I'm going to do it in two ways. One is manually, and then the other one is via StatCrunch. So the first step is, so we did this last time, and then we set up the hypothesis correctly because we want the goal of the company is to have a battery that lasts over 5 hours. And then I remember telling you that because the samples here are recorded in minutes, that is why we put 300 here instead of 5. Is that okay? So that is why you see 300 minutes here instead of like writing 5 hours. So 300 minutes here. And so now we want to determine if there is any evidence that the company has met its goal. So step one is to write the hypothesis. Step two is to be able to check the various assumptions of the t-test. We talked about these assumptions in chapter 17. What are those assumptions? One is randomization. And then two, we know the less than 10%. And then the third one is what? The nearly normal. So for the nearly normal, we can see that the sample size here is less than 20. So we expect the histogram to be what? A bit symmetric. And it shouldn't have outliers or it shouldn't be heavily skewed. If we see that, it means we cannot use the t-distribution. So randomization, we can make that assumption because they didn't tell us how the samples were gotten. So we can assume that the samples were gotten by simple random sampling. And then, of course, since we can see it's a company, we know that definitely they produce many, many batteries. So we can see this 12 here is definitely less than what the 10% of the total batteries they produce. And for the nearly normal, the sample size here, N is what? 12. So let's try to input this data in StatCrunch and then construct a histogram. That is the best we can be able to tell if it's a bit or if it's symmetric. So let's try to do that. So let's go to StatCrunch and then input this data in StatCrunch. So 321, 295. So I have been able to input the data in StatCrunch in a different column. So my column here, I've named it minutes. So you can name it whatever name you wish, but I named mine minutes. So to be able to verify the nearly normal condition, we want to plot a histogram. So we just go to graph, histogram, and then we select the column where we inputted our data. In my situation, it is what? Minutes. So you do so for yours. So minutes, and then, so this is the histogram I have. And so you can see from here, it is fairly symmetric. Is that okay? The other way you could also do that is when you look at this one here, so you can see from this histogram it's what fairly symmetric. You could also compute the mean, the median, and also double check that too. Step 3 is to be able to compute the test statistic, and we have to do that manually. But to do that manually, we need the sample mean and then the sample standard deviation. How do I get that from StatCrunch? So I just go to stats. I go to summary stats, summary stats. I go to columns. I click on minutes. We learned this, I think even before this was part of what you did in test 1. And then I just want the mean and then the standard deviation. I click on mean. I'm using a Mac, so I click on command, and then those are the two things I want. Is that okay? So then I click compute. So I'm going to write the mean. So I have y bar to be 306.25. Now, this is a sample standard deviation, so we represent that by S. I keep repeating, you should be able to know if I write S, what does S represent? It represents the sample standard deviation. Those things are going to be tested on your test 3 and also in your final exam. If you say sigma, you should be able to know it's the population standard deviation. If you see X bar, you should be able to know it's the sample mean. If you see mu, you should be able to know it's the population mean. So S equals 29.31. Those are the two things I need. So now let's go compute the test statistic. So to be able to compute the test statistic, remember we wrote the test statistic. We wrote a test statistic here. It is y bar minus mu naught divided by the sample standard deviation over root n. So it means that my t is equal to y bar. What is my y bar? It is y bar minus mu naught divided by s over root n. Y bar is a sample mean, which is what? 306.25. Is that okay? Minus the mu naught is always here. Is that okay? It's just like what we did with proportion, where P is also the same thing here. So that is what? 300. Okay? And then we divide by the sample standard deviation we computed was 29.31. So 29.31 divided by square root of n. What is our n? We know our n is what? 12. Is that okay? N is a sample size, which is what? 12. Now, input this into your calculator and tell me what you get. I got 0.7386. So this is the test statistic. So we know the test statistic, which is equal to t, is equal to 0.7386. Step 4 is to compute the p-value. Is that okay? So to compute the p-value, remember I showed you last time. First and foremost, you have to ask yourself, look at this alternative hypothesis. Is it one-sided or two-sided? It's one-sided because here is what? Greater than. If it's also less than, it's one-sided. It's only two-sided if it's what? Not equal to. Is that okay? So if this is one-sided and here is greater than, it means that we have to read T, that T is greater than this test statistic. So we are going to do that in StatCrunch. And before we do that, what is our degree of freedom? Degree of freedom is n minus 1, right? Our n is what? 12 minus 1. So our degree of freedom is what? 11. I remember when we were dealing with the confidence interval, I showed you that even if you have the degree of freedom, you can get the sample size. All you have to do is to add 1 to that. Is that okay? So the degree of freedom is 11. And the alternative hypothesis here is what? Greater than. So now we are going to learn how to read the p-value. So let's go to StatCrunch. So we are in StatCrunch. We are going to read the p-value. Remember, this is for the t distribution. Is that okay? Z is for normal, but this is for the t distribution. So to be able to read the p-value, we go to Stats, Calculators, and we scroll down to t, not normal. So you go to Stats, Calculators, and scroll down to t. You click on that, and then you have this thing right here. The first thing you want to do is to put in your degree of freedom. Our degree of freedom here is what? 11. So I changed this to 11. Is that okay? Good. Step 2 is to put in the value of the test statistic. Is that okay? What is the value of our test statistic? 0.7386. So I come here 0.7386. So put in your degree of freedom, the test statistic. Step 3 is you have to look at the alternative. In our case, the alternative was what? Greater than. So we change this to be what? Greater than. Is that okay? And then when you hit compute, it gives you the p-value here. So you can see our p-value is 0.2378. So that is how to read the p-value. Good. Step 5 is that now we need to make conclusion. So to be able to get to the conclusion, you ask yourself, is this p-value large or small? So we are comparing this p-value to what? An alpha level of 0.05. Is this p-value large or small? It's large. Is that okay? So if the p-value is large, what do we do? Do we reject or fail to reject? So if the p-value is large, we fail to reject. Is that okay? But if the p-value is small, then we reject. Is that clear? So we can say that since the p-value is large, we fail to reject H naught, or we fail to reject the null hypothesis. Is that okay? Even in your case, because your exams and everything is multiple choice, you just have to understand some key stuff because those words are written for you. You just have to be able to decide if p-value is small or large, do we reject or fail to reject? Is that okay? And then the last one is that if the p-value is large and we fail to reject, what does it mean? Does it mean that there is enough evidence or there is not enough evidence? What does it mean? Adam, what do you think? If the p-value is large and then we fail to reject the null hypothesis, what should be our English conclusion? Should it be that there is sufficient evidence or there is insufficient evidence? Yes. So if the p-value is large and we fail to reject H naught, it just means that what? There is insufficient evidence or there is not enough evidence. Is that okay? So you can see this is how I concluded here. So we fail to reject H naught. There is not enough evidence that the mean life is over what? 5 hours. So that is how to make the conclusions. Now, the other way we want to do this is to do everything in StatCrunch. Is that okay? Good. So we've done this manually. Let's try to do everything in StatCrunch. So let's go to StatCrunch. We already have our data here, right? So we go to stats, T-stats. One sample with data because we have data. Is that okay? We click on that. Select the column where you have the data. In my situation, it's the minutes. Is that okay? Good. Then the other thing you have to do is to make sure that what you put in the hypothesis correctly here. Is that okay? The hypothesis mu naught is equal to what? 300. And then the alternative is greater than 300. Is that okay? So make sure that you put in the hypothesis correctly here. And then what do we do next? We hit compute. You see, when you hit compute, it gives you the degree of freedom, the standard error. Is that okay? The sample mean. Okay? This is a sample mean, standard error, degree of freedom. This is the t-test statistic. And then this is our what? Our p-value. So you can see our p-value is the same as we got from this one. And then from there, you can be able to decide whether to reject or fail to reject, which we have spoken about already. Let's go to the next example. So for the next example, we are going to save time and do everything via StatCrunch. So this is our next example. So last time too, we were able to write the hypothesis for that. Is that okay? And then you can see clearly here too that we do not have the population standard deviation. So also gives you the idea that we are going to do t-test. So try to input this in StatCrunch, and then we can check everything in StatCrunch. So I'm going back to StatCrunch. So for me, I've inputted the data already, which I named that coffee. Is that okay? You have to do that. So when you do that, to be able to check whether there is evidence that the machine is shortchanging customers, you'd have to go to stats, go to t-stats, one sample, and then with data. Click on that. Now, this is for the coffee data. So I click on that column. That is where I enter the coffee data. Is that okay? I have that. Now, the mu naught here is what? 10. And then here is what? Less than 10. You have to make sure that you are inputting the hypothesis correctly. If you input it incorrectly, it's going to affect your p-value. Does that make sense? Which is subsequently going to impact your decision making. And then I click on this one here. This is a sample mean standard error. So anytime you see t-stat, that tells you the test statistic value. Then this is the p-value. So all you have to do now is to tell me, is this p-value large or small? Do you all agree this p-value here is small? So if it is small, what do we do? Do we reject or fail to reject? Yes, because the p-value here is small, we reject the null hypothesis. Is that okay? So we reject the null hypothesis. The step 3 is that if we reject the null hypothesis, what does it imply? Does it mean that there is enough evidence or there is not enough evidence? Which is which? There is enough evidence. So always have in mind, reject means enough evidence. It goes hand in hand. Is that okay? So since we are rejecting the null hypothesis because the p-value is small, it means that what? There is enough evidence that what? The machine is shortchanging customers. Is that okay? That is how to answer that. And so what I want us to do now is to let's try some examples in chapter 18 homework. So open that and let's start with question 14. Open to chapter 18 homework and let's get to question 14. Question 14. Who would help us with the appropriate hypothesis for the test? Anybody wants to help us? Do you all agree that H naught equals 649? How about the alternative? Do you all agree it should be greater than 649? Why? Yes. So because you can see it's trying to see if the mean number is higher. Is that okay? So this sentence here gives you the idea. Is that okay? Then let's go. Let's proceed. What is a test statistic? So here you'd have to be able to, so it says that we should click on this to view the data. So we click on that, and then I click on this, and then you can open in StatCrunch. Is that okay? Open in StatCrunch. There you go. Okay. And then we go to stats, and then T stats one sample with data. It's called V1, VA1. In my case, I don't know for you. I haven't changed the name. Is that okay? So, and then what was my here? I think it was 649. I can't remember exactly. Let me double check. 649 and greater than 649. Well, okay, it's here. 649, and then here is what greater than 649. And then you just have to hit compute. So my test statistic is what? 4.8943. So let's see, 2 decimal places. So 4.89. And then the p-value. Yeah. So the p-value is 0.30 and then 1. So it says I should round to 3 decimal places. So what is it going to be? 000. Right. So now, who would help us answer this one? Is the p-value large or small? Small. So there is sufficient or there is not sufficient? There is, because if p-value is small, we reject H naught. And if we reject H naught, there is. Is that okay? So there is that the school is, what do you think is going to be here? Greater than. So you're always going to look at the alternative hypothesis to make that decision. Is that okay? So that is why it's greater than. And then let's get to 13. So 13, who is going to help us with the hypothesis? What is the mu naught? What is the null hypothesis? Okay. Do you all agree with that? How about the alternative? Do you all agree with that? Why is it less than and not any other thing? Anybody to explain to us why it's less than? Yeah, so you can see from here, just like he said, they want the sodium content less than what, 325. Is that okay? The next thing is that we want to compute the test statistic. So to be able to do that, we still have to go to StatCrunch. I think let me close this one. Go to StatCrunch and then go to stats, T-stats, one sample, but with summary because we don't have any data. Is that okay? So we go to with summary. We want to input the sample mean. Now you have to be very careful what you input here. The first one says the sample mean. The sample mean. So when you look at this one here, what is the sample mean? So 322.1, not 325. Be very careful. Is that okay? So the sample, you can see that the mean sodium content for the sample was 322.1. So that is the sample mean. So we put that here, 322.1. Then the next one is the sample standard deviation. And you can see with a standard deviation of what? 18. So I put 18 here. The next thing I need to input is the sample size. What do you think the sample size is? Why is it 40 and not any other number? Yes, because you can see that it tested what? 40 hot dogs. Is that okay? So we put in 40 here. Now we need to input these things here correctly. So it's 325. So I put that here, 325. And then the alternative was what? Less than, just like here. Is that okay? You have to input them rightly. And then we click on compute. My test statistic is what? Negative 1.0189. So, and then they want me to round that to 2 decimal places. So negative 1.02. What is the p-value? P-value to 3 decimal places. So it's 0.157, right? Now, what is our conclusion? Is the p-value large or small? So what do? Do we reject or we do not reject? We do not reject, right? Now, is there sufficient evidence or there is not? So since you do not reject, it means there is not. Is that okay? That the sodium content is, what do you think should be here? Less than. Is that okay? Because the alternative here is what? Less than. Is that okay? Let's get to B. Who would help us with B and why? B is saying that will a larger sample size ensure that the regulations are met? What is the regulation? So the regulation is trying to find that the mean sodium content is less than 325. Is that okay? So for example, if they increase the hot dogs to say 400, do you think that they would meet the regulation? If yes, why? If no, why? Anybody to help us? Wait, first and foremost, do you think they will meet the regulation, yes or no? How many of you think it's yes? Just show by your hand. How many of you don't know? Okay. So if they increase the sample size, so think about it this way. If, for example, I pick 5 students and then their average height, it's say 7, and then I add 10 students, their average height, it's also going to, whether it's going to increase or decrease, is going to depend on the people I picked. How about if I pick shorter people? Is that okay? If I pick taller people, the average height would increase. Is that okay? And so, even if they increase the sample size, now they used 40 here, which is good. Is that okay? If they increase the sample size to say 400, it doesn't mean they are going to meet the regulation. Is that okay? So then that is a no. This it's because the sample mean could be larger or smaller. Is that okay? Depending on the samples they pick. Does that make sense? So here is going to be what? No. Let's get to 12. So for 12, it says that a researcher measured the body temperatures of a randomly selected group of adults. The summary of the data he collected are in the accompanying table. So we should estimate the average temperature among the adult population and then complete part A through C. So for example, if I click on this one here, I see that the sample is what, 52. Is that okay? And then when you look at the mean and then the median, they are very close. Does that make sense? You can see in my situation here, the mean and the median are very close. That gives you an idea of what fairly symmetric. Is that okay? So you could also try to look at the histogram too, which is also what you can see it's what symmetric. So you can see that what this condition is met. Is that okay? And then you can also see that this 10% condition is also met because now the researcher measured the body temperature of what randomly selected group of what adults. So you can see that like there are many, many adults, right? And then you can also see from here that the randomization condition is met because it's stated even in the question. Does that make sense? Because you can see from the question that what a randomly selected. So the randomization is also met. Now, the question says we should find the 95% interval, confidence interval for the mean body temperature. Now, we can all confirm that we don't have the population standard deviation. Is that okay? When we look at the summary statistic here, what we have here is a standard deviation. This standard deviation is based on the sample, which is this 52 people. Is that okay? So that is the sample standard deviation. Is that very clear? So go to StatCrunch and then compute the confidence interval. So to do that, we need the count, which is n. So our n is 52. We need the mean. The mean, which is the sample mean, is 98.709. We also need the sample standard deviation. So which is S. I have told you that S is a symbol used to represent sample standard deviation. So you should always know that. So S is 0.6884. So we go to StatCrunch. I think I'm still there. Let me put them here. 98.709. Sample standard deviation is 0.6884. My sample size is 52. Now, what does the question want? The question wants you to compute a 95% confidence interval. So we click on this one and not that one. Is that okay? And then we make sure that the confidence level here is what? Correct. Is that okay? So we click on that one. You could show critical value if you want. And then we click on compute. So the lower limit here is what? 98.517. So 2 decimal places. Let me see. So 98.52 and 98.90. Now, what is the explanation? Who would help us with C? Do you agree it's B? How many of you think it's B? Okay. Now let's get to 4. So we have about 4 minutes. So it's going to depend on how far we go. So if you guys respond quickly, we could be able to finish 4. What do you think the hypothesis is? And then what is the alternative? Why is it greater than Wesley? Yeah, because you can see waiting longer to get married. That means what greater than the average. So what do you think here would be? The independence condition is, so here we can what? Reasonably assume, is that okay? That the independence condition is satisfied. And then the nearly normal condition can also be what? Reasonably, because we don't even know the sample size here. Is that okay? So we are going to make those assumptions. Okay, the sample size is even 40. So we know the sample size, so it's even 40. So we can reasonably assume that it's met, it's also met. And then because the sample size large, and say should be. Now tell me, what do you think C should be? Anybody to help us? So we all agree that it's going to follow the T distribution, right? And when you look at A through C, the test statistic here is correctly written. Is that okay? Because the standard error of Y bar is the same as S divided by square root of N. And if it follows the T distribution, if it's T, it means that what? It follows the T distribution. That means C is out. If this is T, it doesn't follow the normal distribution. It follows the T distribution with what? N minus 1 degrees of freedom. Is that okay? So that alone tells us that what? C is out. Is that okay? Now we are left between A and then B. What do you think is the right answer? The standard error of the sample mean is S divided by the square root of N. Is that okay? Not S. So that means A is also out. What is our N? Our N is 40. So we put square root here, put 40 here. What is our mu naught? Our mu naught is always this. Is that okay? The mu naught is always this, which is 24.7. What is the degree of freedom? 39, because the sample size here is what? 40. Is that okay? Degree of freedom is what? N minus 1. So that gives you 39. Oh, see, I went to write this thing here. 24.7. And then let me clean this one here. 39. Yep. So on Monday, we will do the how to do hypothesis testing via bootstrapping. I'll be quick on that. Then we answer question 15. And then, oh, then it's asking you for the p-value. You can put the p-value in. So to be able to get the p-value, you just need to come here and then click this one, put in the hypothesis correctly, and get the p-value for that. And then on Monday, we would finish this and start chapter 19. So see you guys on Monday. You two have a